going to take a look at derivatives and motion. So we're going to make another tab. I'm going to leave a few more lines because I think I only have like, I'm going to say 4 more things and then we're done with this tab. So I'm going to leave a few more lines, maybe 4 lines. So motion. Alright, so the very first thing you're going to do is draw a picture. Then number 2, as you read the problem, translate it into math symbols. Remember, slope, which is just another word for derivative, is another way of saying rate of change. Alright, third step, what geometry formula do you know to help you solve the question or the problem? This is a listening check. Color the sentence that says on 2, slope, derivative is another way of saying rate of change. Alright, number 4, take the derivative of that formula, and it's mostly with respect to time, or it's the variable in the formula. So sometimes it's with respect to time, and then other times it's the variable in the formula. Alright, number 5, write out the rates to see what cancels, leaving only what you're looking for. I do this all the time just because sometimes I get confused. It helps make sure that you're completely right. Alright, then number 6, substitute the given information into the resultant equation. And finally, number 7, don't forget the units. Okay, don't forget the units in your answer. Alright, so the area is squared units, volume is cubed units. Alright, so with the 2 questions we're going to do, I'm going to pause the video, you need to copy it down. So pause the video, copy that down. Alright, so let's take a look at it. First you draw a picture. So what is this? The radius of a sphere. Okay, so what does a sphere look like? Like a ball. Alright, so we're going to translate the problem into math symbols. Okay, so what is changing? The rate of the radius. So rate of the radius. Remember, that's like the derivative. So dr with respect to time, because the radius is changing at a time. And that's equals 2 inches per minute. And you can see inches would be the radius, minute would be the time. Again, the rate, alright, so the rate of the volume. So the volume is changing. So derivative of the volume with respect to time. That we don't know what it is. When r is 6 inches and when r is 24 inches. So I've translated this whole paragraph into this, and I'm really now finding dv dt. Alright, so what geometry do I know with volume? Volume of a sphere. So let's write down the volume of a sphere. The volume of a sphere is 4 pi r cubed over 3. This is a listening check. Put a box around v equals 4 pi r cubed over 3. Alright, so we're going to take the derivative of that. Okay, with respect to r this time because r is in there. Alright, so taking the derivative of that, we're going to get 3 times what we already had, because I'm bringing the power down. Then I'm going to subtract 1 from the power, leaving 2, all over 3. The 3's cancel out, leaving 4 pi r squared. Alright, now I'm going to write down the rates just so I can see what cancels. So right now I want dv dt. To get dv dt, I have to start with the top one. So I have to get dv, and what do I have? dv what? dr. And then the top one has to be dr, d something, dt. Right, because the t's are going to cancel, leaving dv dt. So that's what I'm looking for. So what's dv dt? Well, dv dt is dv dr, which is 4 pi r squared, times dr dt, which is 2, giving us 8 pi r squared. Alright, now when r is 6, all you're going to do is plug it into dv dt to find out what dv dt is. So you might not be able to see this, but you can listen to my voice. When r is 6, dv dt is equal to 8 times pi times r squared. So the radius is 6 squared, which is 36. 36 times 8, which I'm working out on the side, is 288 pi. Then when r is 24, dv dt is going to be 24 squared, which I'm working out on the side, it's going to be 476. This is a listening check. Color in your work showing how you did 24 times 24. Times 8, which is going to be 3,808, times pi. And the very last step says don't forget the units. Okay, well the units of this is volume. Volume is cubed, so the units are cubed. And what are we working with? Inches. So it's going to be inches cubed over and the time, which is minute. So dV would be the inches, dt would be the minute. So pause this video, copy that down. Alright, so we're going to draw a picture. So it's rising vertically. This is a listening check. Color in example 2. And then it's got a radio station that's 3,000 feet from this launch pad. So 3,000 feet would be the radio station. At what rate is the angle of elevation? So angle of elevation right there. I'm going to put some labels in this. So let's say height would be y and the ground is x. Just because of x and y axis. That's what I like to think of. Alright, so I'm going to translate the problem mathematically. Okay, so it's rising vertically. So it's a 90-degree angle. It's raised 3,000 feet. And from the launch pad, the rate, which is the derivative, remember, right? The rate of the angle of elevation. So that's theta. So d theta with respect to time. That's the question. And then when the rocket is 4,000 feet up, so when y is equal to 4,000, and it's rising vertically at 500 feet per second, so it's dy dt, so how much it's changing vertically is 500 feet per second. So what geometry formula do I know with theta and with height and the base? Well, I know SOHCAHTOA, right? So let me label this: opposite, hypotenuse, adjacent. And so I need O and A. Which one has O and A? It's tan. So we have tan of theta is going to be opposite, which is y, over adjacent, which is 3,000. Alright, so that's what we're taking the derivative of. Alright, so taking the derivative, both of these are functions of time, so I can take the derivative with respect to time. So taking the derivative of tan, I'm going to get secant squared d theta dt with respect to theta with respect to time, which is equal to, remember 3,000 is just a number, so that's going to be 1 over 3,000 derivative of y with respect to time. So again, let me just say why I'm doing that. Both theta and y are functions of t, so we can differentiate both sides with respect to t. This is a listening check. Go ahead and put a box around this entire sentence and color it in. Remember, I'm only trying to get the theta dt, so I'm going to make that the subject. So by dividing what secant squared is the one that side. So taking that there, it's going to be 3,000 secant squared on the bottom, dy dt. Alright, let's substitute what I know. Okay, let's substitute what I know. So I know that dy dt is 500, right? So I'm going to go ahead and put that in the equation. Let's substitute the things I know. Alright, so I'm going to get the theta dt is equal to 1 over 3,000 secant squared times dy dt, which is 500. Alright, simplify that. I can cross out those two zeros, cross out two zeros on the bottom. So I get 5 over 30 secant squared theta. But I can simplify that more. 5 goes into both 5 and 30, so that's 1 time, that's 6 times. So I'm going to get 1 over 6 secant squared theta. Alright, so secant squared, that means I need to plug in theta. I was given y equals 4,000. And so I can find out theta, but I don't have a calculator. So I know that tan theta is y over 3,000 and y is 4,000, so it's going to be 4,000 over 3,000. This is a listening check. Color in the theta dt equals question mark, which simplifies to 4,000 over 3,000 simplifies to 4 over 3, just cancel out the zeros. Alright, so now because I don't have a calculator, I need something that has tan and secant in it. Oh, I know an identity with tan and secant, but it's tan squared, but I can figure that out in a second. So I know sine squared plus cosine squared is 1, and I want tan, so I'm going to divide everything by cosine just because I don't remember it off the top of my head. Remember, I always find it, right? So I'm going to get tan squared plus 1 equals, and 1 over cosine squared is secant squared. Oh, there's what I'm looking for. So I need tan to be squared. So all I'm going to do is just square what I have right now. So I have tan theta, so all I got to do is square it to make it tan squared. So it's going to be 16 over 9. So plugging that into my identity, I have 16 over 9 plus 1 equals secant squared. Now, you know, before I can add fractions, what has to be the same? The denominator. So I'm going to make it 9. Change the bottom, change the top. Now 16 plus 9 is 25 over 9 is secant squared. So now I know what secant squared is. So I can now find d theta dt. So d theta dt is equal to, back with my derivative, what I had solved, right there. So it's going to be 1 over 6 times secant squared, which is now 25 over 9. And that simplifies to 3 goes into 6 and 9 twice and 3 times. And then we're going to do 2 times 25 is 50, keep change, flip. So final answer 3 over 50. So d theta dt is 3 over 50. And my units are going to be, what is theta? Theta is radians, and the time is in seconds. So radians per second. And that's pretty much all there is to motion. So it's just finding derivatives. So let's practice.